Alright, so looking at the discriminant now. So the root of a quadratic equation are the x-intercept of the graph. So when you solve for x for your quadratic, they're the roots, okay? So where they intercept the x-axis, okay? Also called zeros as well. There are three different arrangements of roots you can have for a quadratic equation, okay? You can have two roots, which was most of our examples there, where it crosses the x-axis at two separate points. We can have one root where it turns on the x-axis somewhere, or we can have zero roots where there is no intercept on your x-axis in there as well. So, if there are two x-intercepts to the quadratic equation, y equals ax squared plus bx plus c, then the quadratic equation has two real roots. Okay, so when we solve our quadratic formula and we get two separate answers, okay, we say that we have two real roots. And of course, depending on the value for a, we're either concave up or concave down. And that was all our examples in the previous section. So since the graph consists of both positive and negative y values, so part of the graph's above the axis, part of the graph's below, like what we've done, it is called an indefinite function. Okay, so it's neither positive or negative, like strictly positive or strictly negative. Right, the second condition, if there is only one x-intercept to the quadratic equation, then the quadratic equation has exactly one root. Okay, so as it turns, the root is also the turning point of your quadratic equation there. Okay, and of course you can have the concave down as well. So, if there are no x-intercepts to the quadratic equations, then when you solve using the quadratic formula or factorising, and there are no solution, then we say that the quadratic equation has no real roots. So what that means is there is no x-intercept for your parabola. So it is all of the parabola is above the x-axis, or all of the parabola is below the x-axis. Okay? So if we have all above, then we say it is a positive definite function, and if it's all below, we say that it is a negative definite function. So, to open the idea of what we're leading into with the heading, we are going to have a quick look at the exercise there. So, y equals, it's straight from your notes, so x squared take away 3x plus 2, y equals x squared plus x plus 5, y equals x squared take away 6x plus 9. Okay, also in your notes, you have three parabolas next to them. So you have one doing this, just call it parabola number 1. You have one doing this. You have one doing this, call that parabola 2, and one doing this. Let's call that parabola 3. Match each of those equations, A, B and C, with the correct parabola. Off you go. Okay, I've only spent 2 lessons doing this, your turn. Okay, so you need to go through those equations as if you were graphing them by solving the quadratics by one of the number of techniques I've taught you, and match it up with the correct the correct equation and the correct graph, please. So what are the roots for this one? What are the roots for this one? And what are the roots for that one? Okay, so we can factorise the first one because I can identify two numbers and multiply to give positive 2 and add to give negative 3. So I have the two roots there. So we better do them all first before we answer that. B is not so straightforward. Two numbers multiplied to give 5, same two numbers add to give 1. Alright, so instead of trying to muck around with that, I'm going to straight to the quadratic formula. Okay. Hey? In this course, Robin, yes. Alright, so. One squared, which is 1. Negative 4 times 1, negative 4 times 5, negative 20. So 1 take away 20 over 2. Negative 1 plus or minus the square root of negative 19 on 2. Can that work in mathematics? Did you seriously have to ask that question?
How do you graph it?
We will get to that. Alright, so that one has no real solutions.
Matrix is real.
Right, what about C?
Perfect square.
By what's it called?
Inspection.
By 6 and 9 is by
Perfect square.
3 and 3. No. Yes, it's 3. Negative 3 or negative plus or minus. They're both negative 3s. Yeah. X take away 3 squared.
Alright, so equation A matches which graph?
1.
That Number 1, yep. Because we have two different roots. It means we had two different intercepts on your x-axis. Alright? Now, equation B matches which graph? 3, because there were no real solutions, means there were no intercepts on your x-axis. Okay? So, this one has no x-intercepts at all. So that one matches that one. And by the process of elimination, the one with the perfect square, because it only had one root, means there's only 1 point on your x-axis that we have an intercept. Okay, so what was different about those three equations and the roots that we received? The number of roots. What part of this topic influences the number of roots?
The discriminant.
Which is what?
The square root of b squared take away 4ac.
Okay, so we have to look at what's happening under that square root in the quadratic formula. Okay, what happens if we get a number that's negative and you try to take a square root of it?
0 solutions.
No solutions, isn't there? What happens when we take the square root of a square number?
It's 1, but it's 2.
Actually, not a square number. So what happens when we take the square root of 0?
We did this
1
at one point.
Square root of 0 is 1.
0.
Thank you. 0. Square root of 0 is 0.
We better do harder math.
Okay?
We try and find a solution.
And how does that influence your quadratic formula? So x is minus b plus or minus square root of b squared minus 4ac on 2a. What happens if b squared take away 4ac is equal to 0?
It's a solution.
Yeah, 1 root.
You have one root. Alright? So, when you have the expression equals 0, you have one root. When you have an expression greater than 0 for what's under the third, you're going to get two different roots, aren't you? Because you're adding or subtracting a number that's not 0. Okay? And if b squared take away 4ac ends up as negative, okay, so we can't take the square root of a negative number in this course. We can have no real solutions. Okay, so all that is dependent on what's called the discriminant. Okay, so in the quadratic formula, the expression under the square root will provide the number of roots. So instead of going through the whole formula and getting them, all we need to look at is specifically the discriminant. Okay, so the symbol for discriminant is that triangle symbol that you've all used before. Which is delta, good. No, it's not delta, it's
I was going to say, that doesn't
No,
look
it's
like
not.
delta to me.
No, sorry, you're wrong. Alright, b squared take away 4ac. So, I was trying to think what it's called again. I've completely
You were using physics.
gone.
Probably a different physics.
A small change to, what does it mean? Mikhail, you did this, come on.
It's not delta.
Oh, what is it? No, yeah, I know, but what is it?
Do you know what it is?
It's called delta, but it's not. It's not. That's what it's
It's
called.
not.
It's
It's
called-
not
It's
delta
called
in the
delta.
alphabet.
Yeah.
No.
Not delta in physics.
It's a change in.
Yeah.
Yes.
So delta in physics, but not delta. Right. It's a triangle.
Yeah, it's a different
It's
It's
triangle.
called a triangle.
It's a triangle. Okay, so the conditions are condition. These are all in your notes as well. If the discriminant is greater than 0, okay, so if b squared take away 4ac is greater than 0, we have two real.
The triangle is greater than the circle. Weird
Stop
arrow
discriminating against the triangle.
Equals real roots.
Right, so
Whoa.
We have two real roots. If the discriminant is equal to 0, okay, we have, what should I call it? One real root, or the other terminology is 2 equal. And yes, you need to know that because of further questions they will ask on that concept. Alright, so if the discriminant is less than 0, that implies we have no real roots. Okay, so Rob and Nicola are doing the joys of extension 2 where there's going to be more to that definition for them, so that's why we are saying real, no real roots or 2 real roots, etc, etc. Alright, so that's part 1 and I'll do the examples tomorrow. You'll have the rest of the lesson for a working lesson to get some stuff done and we'll finish off the topic next week.